All right, welcome to statistics. We're going to go through a few things here, um, dealing with data collection, more so with how you're going to maybe present it into charts and graphs, that kind of stuff. I'm going to talk about that in just a little bit. I want to tell you a story just real quick I don't know if you've heard of the name Florence Nightingale. But I was reading some stuff about her, and it's interesting that she actually put together statistical charts and things. This is in the 1850s in the Crimean War, and she did it again for the Civil War then in the 60s. But in the 50s, during the Crimean War, she had been a nurse out on the field and stuff, and as they're bringing in all of these people, a lot of people back then would die. And so what she started doing is actually recording with her statistical stuff, and she put together charts and things to show what she had been recording. But what she was recording was how the people who died, how they died, what they died from. And it was then that she made the discovery that she had more people dying from some form of contagious disease, infection, that kind of stuff, than she had people who actually died from the wound itself, right? And so she was having a lot of people who the wound itself did not kill them, but subsequent infections or diseases of that sort were killing them. And so it was out of that she began to then present to Congress people and stuff like that her findings, to get more funding and things of that nature for a cleaner hospital environment, and to really put an emphasis on that. And that was kind of the beginning of, our understanding of those things, right? And so anyways, that's kind of a neat application of statistics, and there's all kinds of positive things that have come out of life through observation and research and all that. So in your business, your calling, your ministry, your life, however that unfolds, perhaps there's some things in your life that you might understand better if you took the time to be a little more detailed and thorough, and perhaps record some things. Do some life research of your own. One that's very popular a lot of times is, people put together a budget, and in the putting together of a budget, they will actually record a month or two of actual expenses. And in that recording, they're often surprised by the percentage of things that go to stuff that they wouldn't consider important. This is why a lot of people struggle financially, is because when they put together their budget, they know how much rent is, they know how much basically utilities will be, and all of their bills they have a basic idea for. But it's their estimate of their expenditures on a daily basis for things like going out and food and all that stuff that they almost always estimate much lower than what it really is. And the little things that come up here and there, we don't count them like we count the rent and stuff in an exact way. We just estimate, I probably need about $200 for running money for the month or something, and it ends up being $400 or $500, and people end up wondering where all their money is going. And when they actually go in and research it and do some recording and some data analysis, then they figure out, wow, I spent $800 on just little stuff. That's as much as rent. And that happens on a regular basis. And people then begin to say, okay, well, if I'm going to have some savings, this is where I need to start. Then this is where it's all going. Right? So, anyways, there's some things that you might consider for life. So in this lesson, we're going to go through. We'll start with some vocabulary to kind of build some more comprehension in terms of this world of statistics, right? And then we'll go into a few things about how to apply these into like chart form, right? Okay. So the first thing we want to talk about is, and we might have gone over this a little bit already, is variable, right? So the variable is the element of the thing that you're trying to study, right? So it is variable, right? As the name says, it is the element of this that could be different things. So if you're measuring people's height, right? It could be 4 feet, could be 6 feet. The actual score is variable, right? It is changing. If we were all the same height, if we were all the same, there was no variety in life, then a lot of research would be unnecessary. It is the fact that we are all different that makes us have to do research, because it is the elements that make us up that are all variable. There's a lot of variety in life, and so therefore we have to do research to come to an understanding of the broad scope of humanity and all of these different things. And so because if we all were exactly the same, we wouldn't have to research a whole bunch of stuff. We would already know how things are. But because we're all different, it opens up a whole bunch of research where we want to understand our world in total and other people in it. And so this is where variables tend to come in. Okay, so a couple things. Variables will normally come in two forms, right? So you've got numerical, which is numbers, right? And categorical. So numerical, if the height one, I measure them, they're, 5 foot 9 inches. That's a number, right? Or if, 160 inches or whatever, it'd be pretty tall. Maybe, 70 inches or 54 inches, whatever it is, that's a number, right? And so that would be a numerical form of variable. A categorical variable would be if I'm doing research and I asked you a question, do you vote Democrat or Republican, right? And so there's no numbers there, there's categories. One category is Democrat, one category is Republican. On a survey, they may ask you your ethnicity, right? Those are not numbers, those are categories. And so there's two basic types of variables, and they will all fall under either numerical or categorical. All right. Now, under numerical, if it is, if the different answers can vary in magnitude or quantity, then it is called quantitative. All right. Not all numerical variables are quantitative. So to fit the strict definition of quantitative, the numbers have to be potentially different in magnitude or quantity. So to give you an example of a numerical value that is not quantitative would be a zip code or an area code. All right, those are numerical values, but they don't have differences in magnitude, like 5'4" versus 6'4" is different in magnitude, but your area codes are just kind of randomly assigned different numbers, and so that's kind of a nuance to it that I probably won't hold you accountable for that, but just wanted to throw it out there so that you're aware of it. All right. Now, the data values, this is the next one, that are recorded from these variables are called observations, right? Called observations. So that's the technical term for what you're gathering. So I measured them to be 5'4", so that's my observation, right? Is the data that is collected, right? And the variable data, in my variable is called an observation, right? Okay. All right. Now, when you're dealing with a quantitative variable, the two primary things, particularly right now, that we'll go over at an introductory level for for your variables, the two ways that you're going to see these understood the most. One of them deals with the center, and the other one deals with the variableness, right? Variableness, or the spread, or we even talked about parameter a little bit, and then the center, right? So the variableness means I'm looking at how spread out my responses are, right? So in that case, if I'm looking at height, I want to know not only the parameter, what is my lowest and what is my highest, but I want to know like the distribution of them, right? So how many people are under 6 foot? How many people are over 6 foot? That's the spread, the distribution of my variables. So there's different potentials. Somebody could be 5'4", somebody could be 5'5", somebody could be 6'5". So what is the spread? Once I recorded all these different heights of people, what is the spread, right? And I'm just using height as an example. It could be anything that you record that has a numerical value, because these are quantitative. These are quantitative researchers. We'll do categorical in a minute. So for your quantitative ones, the things that you're looking at is the spread out of the distribution of your different responses. And then the other thing that's kind of interesting is that a lot of times for research, these are things that you would want to pay attention to, right, when you're reviewing your data. So this is not so much the collection. Once you collect it, then you want to go back in and be able to review it and get some important insights from it. And so the two things, that's kind of what I'm talking about here, is the two things that you would pay attention to when you're reviewing your results are the spread, what does that spread look like, and what is the center, right? So this is where you get things like your average or your median, remember those numbers. Those are things that deal with your center, right? And then you've got other things that deal with the spread. So that's kind of how you would understand your numerical, quantitative kind of variables, right? When you're doing the categorical variables, kind of the main thing is just your distribution per category, right? So that one's much more simple. So if I'm asking people, are you Republican or Democrat, then the main thing is the distribution between those two categories. How many people were Republican, how many people were Democrat? That's pretty easy to understand. If I ask how many people are white, how many people are Asian, how many people are Hispanic or whatever on a survey, then the thing that's important then is just how they're distributed. What does the distribution look like, right? Okay. Now, I want to talk just a little bit about different types of graphs, right? So when you collect all your data and then you want to analyze it, right? One of the easiest ways to see these things, we're still trying to see this information. What is the center? What is the spread? What's the distribution? And so the easy way to see that, as opposed to just looking at a bunch of data, is to develop a chart, right? And so this is the stuff we're trying to find out. The easiest way to see that is by developing a chart, right? Okay. So when you're dealing with quantitative data, right, versus categorical data, sometimes there's different charts that fit better with those different types of data, right? So for categorical variables, you're really looking most likely probably for either a pie chart, right? Yeah, we've all seen those, right? Or you're looking at a bar chart of some kind is an important one, right? Where each, you know what a bar chart is, where each of the different bars represents something. So these are your key ones for categorical responses, right? So maybe if this was it, I'd have maybe one bar represents Republican and the other bar represents Democrat. And I can see it very easily then with that chart. Maybe I had 10,000 responses, takes it all and puts it into this, makes it very easy for me to see. The pie chart is also good. Where the pie chart suffers, and this is important, say if you've got a business and you're trying to, so don't just think of this as statistics, try and apply this to ways that it can help you. So you would say, okay, if I've got a business, maybe I have to put some reports together. Or maybe I need to show my employees their productivity levels or something. Maybe I'm in marketing and I need to prepare a marketing report for my boss and to show him or her what, maybe I've got 4 different types of marketing that we're doing, and I need to show them the sales that have been generated from each of these 4 types, right? So there's a lot of reasons why you may have some data that you want to put in an easily recognizable form, right? And so, a lot of times on the workplace, you may want to put it together in something that can be seen. Maybe you're tracking the attendance of your church services or your ministry services. Instead of having, 80 different services all in one thing, maybe you put it into some kind of a chart. Maybe by month or something, so that you can see, does the summertime go down or up? Because depending on what part of the country you're in, summertime can go down or up, or wintertime can go down or up, depending on where you're at. And so different parts of the world respond differently to different times of the year. So maybe as a minister, you may want to record that, so that okay, if every summer our attendance is going to be down 20%, right, then maybe I need to save a little more on the other months to offset the lack of tithes that are going to come in over the summer, right? So different things. The weakness of the pie chart that I was getting at is, what if I've got a few things that are all really small and then a couple things that are big? The really small ones tend to get lost in the pie chart. It's hard to separate those little slivers, And a lot of times what they'll do is they'll stick the number out to the side or something, with a little line. But still, that can be a weakness of the pie chart. And so, understanding what is going to make your presentation most easily understood. If you've got 12 things that are really small and 1 or 2 things that are big, this pie chart may not help you as much, because it's going to cram everything into one spot. All right. Okay. So let me also talk, before I get into quantitative charts. Have you heard of Pareto's principle? I know we've gone over that in several classes. So if you've been through a few of the other classes, you would have heard that term, or maybe just in life you've heard it. But the basic idea behind the Pareto principle is that 20%. This is a major application of it. I'll show you what the actual Pareto principle is here in a second, because it's not this. But how we hear it interpreted quite a bit is that, say, 20% of the people do 80% of the work, or 20% of the people in the church give 80% of the tithes. That kind of thing. That's the Pareto principle. And so a Pareto chart is a bar chart that is organized from highest response to lowest, right? So the first bar is whatever is the highest number of observations, right? Because remember, observations is whatever the data was that was collected for that variable. So if I'm testing, how many members in our church work in education versus how many members of our church work in business, or whatever it is. Say if the most of them work in education, then that would be the first bar. And then whatever the second level response is would be the second, and so on. And then they go in a descending order down to whatever was the least response. So this is a Pareto chart. It's a bar chart that is in order from greatest to least. And so in the doing of the Pareto chart, what he discovered is that most of the time, 1 or 2 categories will have the greatest number of observations. So that's the actual Pareto principle, is that when you're doing one of these charts, typically a small number of categories will have a significantly higher number of observations. So you will get a high number of observations in just a couple of categories, is the Pareto principle. It was based on statistics with these charts. So when we apply that principle, though, we put it into application kind of terms and say, well, 20% of the people give 80% of the tithes, or things of that nature, and we apply it in different ways. But that is the Pareto principle, is that a small number of categories will often yield an inordinate number of observations or responses, right? Okay. When we get into quantitative variables, there's a couple of charts that you could use that are lesser known, right? There's one called a dot chart, right? and it's a line, and then you have each response underneath, right? And then the number of observations for each one gets a dot, all right? So this one's got 5 dots. It had the most observations. And so you've got these different dots. Well, the trouble with this is what if you have a whole bunch of responses? And, it kind of becomes hard to draw one of these. This is only good, and even that is not all that great. But even if it was, it would only be good on a small data set, right? So with quantitative variables, normally we come back to, it looks like a bar chart, but it's not called a bar chart. But it looks just like one. It's the same basic thing. But if it's a bar chart that is used for numerical values, it's not called a bar chart. It's called a histogram. A histogram. Okay. Histogram is a bar chart for numerical values. So it's a bar chart if it's categorical. It's a histogram if it's numerical values, right? So, but it's the same basic concept as a bar chart, right? And then when you put these together for these numerical values, because it's numerical, it's not categories, you may have a whole bunch of responses. So like if I did height, I may have 5 foot, 4.5 inches, 5 foot 4 3/4. I could have all of these different things. So to have a bar for each one of those responses may not be realistic. So a lot of times in the histogram, you will have a range. And so I may say 4 foot to 5 foot, or 4 foot to 4.5, and then 4.5 to 5, whatever it is. The ranges should be consistent though for each bar, right? In order to make the look be meaningful, right? Because you also want to look at the shape, and there's some things you can tell from the chart. But if your ranges for each bar are not consistent, then the information you get from looking at the shape of your histogram is not. It's not going to be valid. It's not going to help you because each bar was a different range, right? So whenever you establish your ranges, they should be consistent. Okay, so let me give you a couple other things here, and then we'll close out this lesson. When you observe the shape, right? Say if on my histogram here I have something like this, and then all these ones over here are kind of small. I can tell all of a sudden then that most of my stuff is clustered into this one section of responses, right? And so that may be helpful to me for whatever my research is. I can look at this very quickly and realize, wow, not much is going on over here. Almost everything I need is right here in this zone. Maybe I need to focus my efforts there, right? And so, as a researcher, maybe by the time you've put together all this research, maybe you know all of this. But the purpose of putting it into the chart is so that you could easily show this to someone else. Because they're not going to look at your data. They're not going to go through your research reports. Most of them aren't, right? Most people want to see something very instantly. And so you put together all this work, put it into this chart, you show your boss, you show your customers, whatever, and then all of a sudden they can quickly see, wow, that's pretty impressive. Right? And then all of a sudden it becomes apparent based on your actual research that this is where it's at, right? And so these are things that you can use in your marketing reports, your flyers, your brochures. You may want to do some research on your product. You may want to do some research on your customers and make that part of your materials. Put it into an easily recognizable form, right? So that your people can, whoever's looking at it can see instantly, oh wow, that's it right there, right? Okay. Now let me give you just a couple more vocab words, and then we'll get you out of here. Whatever bar is the highest, right, is called your mode, right? That is your mode. It's the one that appears the most often, right? So if it's the highest, that means it was the one that had the most responses. That's your mode. Now, occasionally, like this one, these two are basically the same. So that would mean that I have a bimodal chart. If there's only one that's the highest, and it's clearly the highest, then that's your unimodal, right? So it's one response that is clearly the highest. But sometimes you have bimodal, right? if you had a response, say, just to give you an easy one, this one wouldn't tell you much because you already know this off the top of your head, but just to give you an example, if you ask people what their voting preference is, and you said Democrat, Republican, or Independent, you're going to mostly get Democrat and Republican, and they're probably going to be fairly close to being even in number, so you're going to have probably what you would consider a bimodal chart there. Now, that's something that you already know offhand, so that amount of research wouldn't do you much good. But there are other things that you're doing research. Maybe you've got 10 products that you're selling, and you do research on which ones your people like. Maybe there's 2 that stand out the most, right? And so that information is important. And so whenever you're doing this type of stuff, it is your observation of the results and how you interpret the results that's really beneficial, right? So you do all the work of collecting the data, interpreting it, and putting it into a form like this so that you can then look at this very easily and understand the data and then apply it somehow in your business or in your ministry, in your life in some way. So you don't want, the statistics is not just about busy work of collecting data. It is collecting it to get it to this point so that you can clearly see the results and make some inferences and some decisions based on what you see. That's why this chart part, I'm a poet, didn't know it. The chart part is the really good stage here. You don't want to end before you get to this so that you can be able to interpret in an easy way, right? Because that's really the goal of all this hard work of statistics, is to be able to have some decisions that you have interpreted out of all of your data collection, right? Okay. And then just one last thing. The shape of the distribution can be either symmetric or skewed. So you'll need to know those 2 words, symmetric or skewed. I don't know if you've ever seen, like this. This is what they call like the standard bell curve, right? So if you draw the middle line here, it's the same on either side. So this is a classic symmetric result. So, if whatever you measured, when you draw the line down the middle, right? So this is your chart here, right? And these are all your results. You draw the line down the middle. If what's before and what's after is essentially the same, it's symmetric. If it's skewed, then that means one side is different than the other side. So in that, maybe we get rid of this. Maybe it looks more like this, right? And then that's not symmetrical at all. You've got a lot more on this end than you do on this end, right? And so you'll need to know that if you're finding out the difference between a symmetrical and a skewed, right? If it's symmetrical, then that tends to tell you that there's something very important about that center, right? And if it's skewed, that may tell you some information. So if you were to do the average income of everyone in the United States, it would look more like this, right? Because there's quite a few people out here on this end. Like if this was money, like say 10,000, 20,000 a year, 30,000 a year, 40,000 a year, all the way up into the millions, you would have some people way out here on this end, but not many. It would be real low like this. And the majority of your people would be over here in the 100,000 and under salary range, right? And so that would be a skewed distribution. And so that's just the vocabulary. The real key is then being able to look at these things for whatever your question was. Remember we talked at the beginning, normally when you do this, you have a question or something that you're trying to find out. And when you get it to this stage where you've collected the data and you've turned your data into some form of a chart, then you can start making some logical inferences from what you're seeing here. So you want to bring it to this point, because then it's very easy to look at this and begin to make some well thought out decisions based on how you've gotten this. Okay? All right, so that's all we'll do for today. I want to, just trying to build this base of understanding the purpose of statistics, that we're trying to answer some question. We're going to gather in a whole bunch of data, right? We're going to insert that data into some form of a spreadsheet, and then that data in the spreadsheet we can then turn into a chart, and then we take the appropriate chart and analyze it to see what the data is telling us, right? Okay, so that's all we'll do for today.